Hi class, in this video, I'm going to show you how to do hypothesis testing with Excel. In this example, we're going to assume sigma for a population is known and our hypothesis test is about the population mean. So the file is titled HYP hypothesis sigma known. You can find this file in our course note. And the data is here in the first column. So we're going to use this data as our sample points to test our hypothesis about a population mean. The null hypothesis is, in this case, mu equal to 295, and the alternative hypothesis becomes mu is not equal to 295. And we're going to assume the alpha in this example is 0.05. So the sigma given, we're going to key in the value of sigma now for the population is equal to 12. And then we're going to first start by finding out the sample size, and the function we're going to use is called count. So key in the function, select all the data points you have from the first one up to the last one. So the last one happens in the cell A51. Close the bracket. Now we see we actually have 50 sample points, and then we're going to look for the sample mean equal to average. Functions here, same thing. Select all the sample points, and now we know it's from A2 to A51. I'm just gonna write it in this way. So the sample mean for example turns out to be 297.6. Okay, now we're gonna find out the hypothesis value. We're gonna key in the hypothesis value here, 295. And starting by finding out the standard error, which is sigma over root n. So sigma is in the cell, just double click it, single click it, divided by square root, that's QRT. Now the n value is here, so select this cell, close the bracket, there we have it. That's the standard error. So the test statistics, that value becomes x minus mu over sigma x. So that's sample mean minus, that's our mu value. So I'm going to use this x minus mu divided by sigma x. Divided by sigma x value is here in the previous row. So there we have it. So that's the test stats. Now, if we're doing a lower tail test, in order to find the p-value, the function we're going to use is called norm as dist right here. So this is function return the standard normal cumulative distribution, okay? And then the input comes from the test value z. Okay, close the bracket, there you have it. Now, if this happens to be an upper tail test, all we need to do is to use 1 minus the value we found in the lower tail, there. And in this example, we actually are doing a two-tail test. So the p-value here is going to be 2 times the mean value among either the lower tail and the upper tail, whichever is smaller. There. So it turns out the p-value for this test is equal to 0.1255, which is roughly 0.13. Now we can compare it with our alpha value, which is given at 0.05. And apparently the p-value is bigger, and that means we cannot reject the null hypothesis.